Dear friends, in this video we are going to know about open circuit test and short circuit test. From open circuit test we are going to derive exciting parameters R0, X0, and from short circuit test we are going to calculate the circuit parameters, equivalent circuit parameters. Okay, the first open circuit test. This is the experimental setup for open circuit test. Let the transformer is 2 kVA rating and 230 bar 115 volts. Okay, so 230 is the HV voltage, 115 is the LV voltage. So here the primary winding is LV and the secondary winding is HV. Now HV is open circuited. Okay, so now coming to operation. When we give AC supply to the power and close the switch, we get power into variac. By changing the variac, we are going to set the rated voltage of primary side. So now the rated voltage of primary is 115 or 115 volts. So now after setting the voltage 115 volts in voltmeter and note down the V0, I0 and W0. Okay, so already we know the no load power W0 is equals to V0 I0 cos phi naught. If you want to calculate cos phi naught which is no load power factor, cos phi naught is equals to W0 by V0 I0. Okay, so this is cos phi naught and this is no load power W0. No load power W0 is equals to iron loss, total iron loss. W0 gives total iron loss. Okay, and now I0 has two components. I0 has two components. One is core loss component IC, another one is magnetizing component IM. The core loss component formula is I0 cos phi naught and the magnetizing current I0 sin phi naught. Okay, so now cos phi naught, already you know the value of formula for cos phi naught. So with the help of W0, V0, I0, so we are going to calculate cos phi naught. And what about sin phi naught? If you want to calculate sin phi naught, first we are going to calculate phi naught. Okay, so phi naught is equals to cos inverse of the given value. So when you know phi naught or when you calculate phi naught, so put sign in front of phi naught, we get sin phi. Okay, so if you want to calculate sin phi naught, first you calculate phi naught. Phi naught is equals to cos inverse of value. So we get phi naught. Phi naught into sin, we get sin phi naught. So in this way we are going to calculate I0 cos phi naught and I0 sin phi naught. Okay, and what are the exciting parameters? The exciting parameters are R0 and X0. R0 is equals to V0 by IC. X0 is equals to V0 by IM. So already we know IC is equals to I0 cos phi naught, IM is equals to I0 sin phi naught. So V0 is the no load voltage, which is 115 volts. So in this way, with the help of open circuit test, we are going to derive the exciting parameters R0 and X0. Okay. So now coming to SC test, short circuit test. So I will change this open circuit test by small variations. So first of all, this is short circuit test. So that's why we are going to short with copper wire. Short circuit. Okay. And HV and LV interchange. So now the short circuit side or secondary side LV and primary side HV. So HV 230, LV 115. So now 115 volts is short circuited and 230 volts is connected to supply. So this is short circuit test. Okay. So here VSC short circuit voltage, ISC short circuit current, WSC short circuit power. Okay. So from short circuit test, we are going to derive the circuit parameters, equivalent circuit parameters. Okay. So first of all, how to conduct this test? So this is the experimental setup for short circuit test. Okay. And when we close the switch, by wearing the switch, we get supply. Remember, in short circuit test, we put concentrate on ammeter. So why? Because when we change a small voltage, it draws more and more current. So that's why first calculate rated current of the circuit. So how to calculate rated current of this particular circuit when transformer rating is 2 kVA? So when transformer rating is 2 kVA, I is equals to 2000 VA by, so it is connected to 230 volt side or HV side. So that's why 230. Okay. So now I is equals rated current, I is equals to approximately 8.69 amps. So now by changing the variac, we are going to set the ammeter value 8.69, which is rated value. Okay. And now note down VSC value, WSC value by setting ISC, and note down the VSC and WSC. So now we have VSC value, ISC value and WSC value. Okay. So WSC is equals to VSC ISC cos phi SC. So short circuit power factor cos phi SC is equals to WSC by VSC into ISC. And we have one more formula for WSC. WSC is equals to ISC square R1E, where R1E is the resistance, total resistance referred to primary side. or equivalent resistance referred to primary side. So actually WSC is equals to total copper loss. Total copper loss. So WSC is equals to I square R, ISC square R1E. So with this equation, we may calculate R1E. R1E is equals to WSC by ISC square. So now we get one parameter. Okay, next Z1E. Z1E is equals to VSC by ISC. So directly with the help of voltmeter reading and ammeter reading, we are going to calculate Z1E. Okay, so now Z1E is ready. So the final parameter is X1E. If you know Z1E and R1E, so already you know the formula for X1E is equals to Z1E square minus R1E square. So finally we get X1E. So in this way we are going to calculate exciting parameters R0 and X0 from OC test and circuit parameters, equivalent circuit parameters from short circuit test.